Thank you, Tiana, for your kind words, and welcome everybody to this presentation. For today, we will study rootstocks and scions, the combination of these two. We will learn or review some basic generalities, and then we will share from the growers how is the experience. So my first 20 minutes, as I mentioned, I will go with some root characteristics, general characteristics, and also describing what is the mainly rootstocks that we can find here in Washington nowadays, and basically giving the characteristics that these particular rootstocks have. Also, I will present with the data collected from the rootstock trials that Washington Tree Fruit Commission has established in Washington, provide some or illustrate how the rootstock and the environment influence the vigor and the characteristics of the varieties, such as alternate bearing and production. I will finish with some conclusions, and after that, we will have a video that is about 10 minutes where 3 growers from Washington will share with us the experience that they have using one rootstock-scion combination that fits their goals in their orchards. We will finish with 10 minutes Q&A session. Let's see. So first of all, I want to make this comparison between what it was an old orchard in the early 1900s and what we see right now in the orchards here in Washington. As you can see in the left picture, this is a typical tree that was present in those orchards. And as you notice, it's really vigorous. So the trees were huge. And because of that, just 50 or 70 trees could be planted in an acre. And then the growers have to wait about 6 to 10 years to get their first fruit production. And even though the production was not good, like it was really low, and because of the tree architecture that these trees had very difficult maintenance of the orchards, and also the labor was inefficient. So nowadays we see kind of the opposite situation. Where we have some small trees, and because they have small trees, they can fit in 1 acre. They can fit more trees in 1 acre, like about 1,500 or more. The time waiting for the first fruit production is reduced to 4 to 5 years, and in some cases even less time to wait. And the production of the fruits is high, with high efficiencies in their maintenance. So this transition from these old big trees to these small trees, more easy to handle, like simple, has been given because of the rethinking in the orchard production, as well in the need to increase the fruit production. So new systems, new technology, and new plant materials with higher qualities has been put in place for getting until this moment. So part of the plant material that we needed for getting to highly productive orchards are the rootstocks. So what are rootstocks? So I will go to the basics here. And we know that sometimes we call it root, sometimes a stalk or rootstock. And it is basically the lower part of a grafted tree or a composite tree, as an apple tree in their orchards. In the pictures that I am showing here from orchards here in Washington, taken in different times during the year, we can recognize the rootstock because it is the 3 or 4 inches of like a bigger stump of the stem or bigger part of the tree there. So this is the part that we see from the rootstock, but it also includes all the root system that is anchoring the tree. We have here then the scion, so the apical part, the portion that we see in the orchard. So we have the rootstock and the scion, and we can recognize it because of the more wider stems on the base. Since A grafted tree, it is basically a combination of two plant materials to make one composite tree. There's a lot of complex interaction that has to be carried out to get the results that we want, to get differences in vigor, high productivity, tolerance to specific diseases or environmental conditions. For selecting this type of rootstocks, there has been breeding programs that has been established around the world. And for Washington purposes, most of the rootstocks that are planted currently are coming from the Geneva breeding program, rootstock breeding program in New York, the East Malin Research Station in England, and the Budakovsky Institution in Russia. Most of the breeding programs look for different characteristics, but among the main ones are the looking for dwarfism, rootstocks that gives precocity to the orchard. So precocity is shortening the time that you have to wait since you plant the tree to get the first fruit production. Productivity, also rootstocks that are modifying the tree architecture, conferring resistance to diseases and tolerance to different environmental conditions depending on the region. The rootstock-scion combination with these kind of complex interactions that we still don't know very well, they will give results related with these traits in higher or lower proportion depending on the plant, on the genetic component. But there's also an important component in this interaction, and it is the environment. The environment plays a big role in how these two plants interact to make a composite tree and the characteristics that we will see in the orchard. In Washington, currently, in the orchards, we have noticed that there are more than 30 rootstock types that are planted. Most of them are belonging to the Mullen clones, more specifically the M9 clones, following by the Geneva series. Those are the rootstocks that are being produced by the Geneva breeding program, and also from Russia, from the Budakovsky Institution, particularly the B9 and B10. Because there is a lot of rootstocks and information that we can get from there. I will just try to compress in the main characteristics that most of the time are looking for. And it is in this graph where, where in the left side, we can see characteristics that are dwarfism, precocity, yield, disease resistance, cold hardiness, and the arrows will indicate if the rootstock has higher or low impact or show high or low these characteristics. For example, the M9 clones, that includes the M9T337, as well as the Pajam 2 that it is popular here too. We can see the following. So this rootstock is in the dwarfing section, has high precocity, good yield, but the disease to resistance is somehow limited. It is very susceptible to fire blight, and it is fairly to crown and rod roots. For the Geneva series, we have also the G41. This is also a dwarf rootstock with, again, high precocity, yield, disease resistance, and cold hardiness. So this is good. The only thing, the big issue with this rootstock is that not all the varieties are compatible with this rootstock. Some, like Honeycrisp Bengala, we have seen that there are problems in the union, in the grafting. Meanwhile, other cultivars like Jazz get better results. Another one is the G935, dwarf, high precocity, high yield, really cold hardy. The biggest problem with this one is that it is highly sensitive to viruses. So if you are planning to use the 935, be sure that your scion is virus-free. Other important characteristic that has been noticed in the rootstock trials here in Washington is that the size of the tree will change with the variety. For example, with having the G935s with delicious, get a tree that is a little smaller than M9, but if it is combined with Fuji, it will be taller. So now we are seeing the interaction of these rootstock scion combinations. We have the G11, and this is now getting into the semi-dwarf rootstocks area. Even though it's a semi-dwarf, still has a lot of precocity, good yield, but the resistance to diseases are variable. So for the replant tolerance, it is good. Have some issues with fire blight, and doesn't like at all the aphids. It is really cold hardy one. The other one, semi-dwarf but more vigorous, is the G890. The precocity has been, it is not so precocious as the previous ones, but it still has a good yield, good disease resistance, and hardy one. Since it has a big vigor, so there could be some issues with the bitter pit. Since also the vigor and has a big root system, so has good anchorage, so that could be a freestanding tree. Or it can be used with scions cultivars that have low vigor. Similar situation is happening with the 969. Their characteristics are very similar to the 890, that it could be worked as a freestanding tree, highly vigorous, not so precocious, with high yield, high resistance, and high cold hardiness. In Washington, it has been observing the rootstock trials that even though it seems that it is not as precocious as the other ones, in the central area of Washington has reported higher yields than other rootstocks, even in the second or third year of being planted. Now we go to the Budakovsky series, where we have the B9. That is the smallest tree that we have right now. It is but even though it is small, has high precaution, it is very precocious, good yields. The resistance is kind of yes and no. It's highly resistant to crown rot, but it is vulnerable to fire blight. Most of the time happens that they are very susceptible when they are very young, but once the trees get older, they get more tolerance to this disease. It is a really good cold hardiness one. And the final in these examples is the Budakovsky 10, the B10. It is still a dwarf, but it's not as small as the B9. With good precocity, with yield, with good resistance to fire blight, in contrast to the B9. And also, but it is susceptible to the aphids. A really cold hardy one too. So as you can see with this, in summary, you can see in this slide is that the rootstocks in Washington goes from dwarf to semi-dwarf, and they have been planted because they have good precocity, yield, and cold hardiness characteristics. Most of the time they have good disease resistance, but depending on the rootstocks, you will have more resistance or more tolerance to certain diseases than to other ones. And now I will change topics to show with data how the rootstock and the environment affect the growth of the plant. So just keeping in one variety consistent, that in this case is Honeycrisp, and taking the data from two rootstock trials here in Washington, one in the north area of the state and the other in the central part of the state. where more than 14 rootstocks were evaluated. And for simplicity, I am just taking as an example 6 or 7 here in these graphs. And in these graphs, I'm showing the vigor and the fruit production. When the rootstocks, or in the rootstocks trials that has been planted in the north area, we can see that the Geneva series G210, 210, it is the one more vigor with this trial. And with this vigor, they have a low fruit production compared with the rest of rootstocks evaluated. In the opposite, in contrast, we have the Budakovsky, the B9, which is a dwarf, like low vigor, and the productivity is high. However, this pattern is different in the central area of Washington. As we can see here, the vigor is consistent. Just the G210 is the highest, and B9 is small and has a similar tendency to rootstocks. But the fruit production in the central part of Washington was not as affected as it was in the north. Basically, it is similar to the rootstock that is a dwarfing rootstock. That's the B9. So small vigor, but still the fruit production is similar to the one that has the highest vigor in the trial. So we can see here that the environment is having an effect on them. And with environment, not just the weather, not just the soil, but also the maintenance of the orchard could have an impact on them. Other parameter that shows this relationship between the rootstock and the environment is the alternate bearing. So alternate bearing, as all of you know, is the alternation between seasons of high production with seasons of really low production. And in this experiment, where they were evaluating treatments for replanting with the rootstock trials in the south region of Washington, where they evaluated 14 rootstocks. And for simplicity, I am taking just 4 and the more representative here. I calculated the alternate bearing index using the fruit production from the second year of planting to the 5th production year of being planted to analyze this index. So the treatments were a control where the ground was the same with no pesticide, and where the ground was treated with 2 different pesticides for replanting diseases. The ABI index that was calculated, that goes from 0 to 1. If the index goes to 0, it means that it is non-alternate bearing, so it doesn't have this alternation in fruit production. If it is 1, it is a strong alternate bearing cultivar. At least with this set of trial, none of the rootstocks get to the non-biennial part, but there's some differences. If we take B9, we observe that with no pesticide in the control, so in the control ground, the index was in the middle. But then when the pesticides were put in place, the alternate bearing trait was affected, like it was more drastic. M9 is a strong alternate bearing, and the treatments didn't make too much of the change. But with the M26 and the G214, they became stronger alternate bearing when they were planted in the treatments for replanting. So now we can see that even the soil and how it is treated could affect the traits of our plants in the orchards. As some conclusions from or take-home points from this presentation is that the rootstocks are interacting with the scions and meaning the cultivars, and provides the different characteristics that we are looking for in the orchard, such as resistance to diseases, tolerance to environmental conditions, fruit production, precocity, among others. Also, with these previous examples that I was presenting, the performance of the rootstocks can vary based on the environment that they grow. In Washington, most of the rootstocks that are planted are coming from the M9 clones, the Geneva series, and B9 and B10 rootstocks. One thing that I maybe forgot to mention, but I think that it is important, there's no an ideal rootstock. Unfortunately, like not all the desired traits can be found in a single rootstock. So because of the interaction with the scion and with the environment. With this, I give you with some references that I use for this presentation. And then I will let Tiana helping us putting the video on. Thank you so much.